Nuclear energy is based on the fission of large atoms, such as uranium-235. Fission occurs when a neutron splits the uranium atom into two smaller atoms. These fission products are radioactive. A nuclear reactor generates a wide variety of fission products as it produces energy. Many radioactive elements within the periodic table of chemicals are fission products. In an accident involving radioactive release, radioactive gases such as xenon and krypton and volatile elements such as iodine, cesium, and tellurides are dominant fission products that are released into the environment. Radioactive pollutants are dispersed by wind in the form of a contaminated air mass called the plume. Organisms are exposed to radioactive particles in the air, external irradiation by the plume, and internal contamination by inhalation. The risks of being exposed are gradually reduced as the radioactive plume becomes diluted in the atmosphere. Rain or snow can cause the radioactive particles in the plume to fall quickly to the ground, contaminating all things they touch. Organisms are externally irradiated and receive internal contamination by the ingestion of vegetables or fruits or products from the food chain, such as milk. Among the many pollutants of radioactive releases, iodine and cesium are the most important in terms of impact on the environment and health risks. The thyroid gland, especially of young children, is very sensitive to radioactive iodine. That is why iodine is of concern when the plume passes and also in the first weeks after an accident. Because iodine-131 has a short half-life of about 8 days, it disappears almost entirely by radioactive decay within 2 months. Then radioactive cesium becomes the main source of contamination. It can remain within the upper layers of soil for decades, where it is accessible for plant roots and subsequent transfers within the environment. Climate and weather have a very important role during a nuclear accident. During dry weather, the radioactive particles settle under the influence of wind and the turbulence that the wind generates. During rain and snowfall, however, water drops or snowflakes bring the particles to the ground and contaminate the terrestrial environment. Maps of radionuclide concentrations show hotspots that correspond to regions with rain causing an increased deposition of radioactive contamination. On March the 12th, radioactive releases began due to an explosion and damage to the roof of a reactor building. Discharges continued for many successive releases, depending on the events taking place at the different reactors. From March 12th to the 14th, the first radioactive plume was carried by the wind towards the Pacific Ocean. The air currents changed, and the next plume reached the Tokyo area on March 15th. The same day, major releases were dispersed to the northwest, together with heavy rainfall and wet snow, causing important radioactive deposits on soil and plants. Significant radioactive releases continued until March 25th, lasting for nearly 2 weeks. The IRSN, the Institute of Radioprotection and Nuclear Safety, estimated the radioactive releases to be 1/10 of the iodine releases from Chernobyl and 1/3 of the cesium releases from Chernobyl. However, these quantities were estimates because they were dispersed over the Pacific Ocean where no measurements were taken. The radioactive plume was the first concern of the authorities. After evacuating the population within 20 kilometers of the plant, the Japanese government asked people living in the area of 20 to 30 kilometers from the plant to seek shelter and to stay in their homes. Sheltering is often an effective way of reducing exposure during the early phase of an accident. A few weeks later, the U.S. Department of Energy published a map of cesium deposition determined from measurement made from passing aircraft. The map highlighted an area of contamination that is 20 kilometers wide and 70 kilometers long, northwest of Fukushima Daiichi. These deposits corresponded with the radioactive release of March 15th after an explosion at Reactor Building 2 in combination with local heavy rainfall. In red, we can see the concentration of cesium with a level as high as the most contaminated areas around Chernobyl. The Japanese authorities decided, therefore, that additional evacuation was necessary. In the summer of 2011, Japanese universities, under the supervision of the Ministry of Science, initiated a systematic campaign of sampling and analysis of the contaminated soil. This campaign has shown isolated patches of contamination related to local rain or snowfall that are beyond the main area of contamination. Citizens took initiatives like this Facebook group, whose members have purchased radiation detection instruments. These instruments have allowed them to measure radiation and to publish their own maps corresponding here to the suburbs of Tokyo. All these maps are essential in managing the post-accident phase. In addition to the evacuation of the population, the maps identify areas that will remain contaminated for a long time and will require continuous monitoring, especially the agricultural products. The Fukushima accident resulted in the largest release of radioactive substances ever observed in a marine environment over a short period of time. The sea was first contaminated by fallout from the radioactive plume dispersed over the ocean between the 12th and the 23rd of March. Then it was polluted by liquid radioactive discharges directly into the sea, mainly between March 26th and April 10th. The ocean currents disperse and dilute the radioactive pollutants away from Japan and towards the coasts of the United States. Nevertheless, the area close to the shore of Fukushima is likely to remain polluted for a very long time by radioactive elements that settle into the ocean sediments or by terrestrial deposits that will wash and erode to the sea. The authorities will therefore closely monitor the seafood when fishing activities resume. Since there is very little exchange of air mass between the northern and southern hemispheres, the atmospheric dispersion of the plume affected only the northern hemisphere. Radioactive pollutants reached North America on March 16th. Northern Europe on March 21st. And France on March 24th. France measured the same level of radioactivity in the air from Fukushima as occurred in the 1960s when nuclear weapons were tested in the atmosphere. However, radioactive levels are far less than what was observed after the Chernobyl accident in April of 1986.